Hello everyone, my name is David and today I'm going to start recording this video. Nothing in the universe is static. In the Milky Way, billions of stars orbiting the galactic center. Some, like our sun, are pretty consistent, keeping a distance around 38,000 light years from the galactic center, completing an orbit every 230 million years. This dance is not an orderly ballet, more like a skating rink filled with drunk toddlers. This chaos makes the galaxy dangerous. Our solar neighborhood is constantly changing, with stars moving hundreds of kilometers every second. Only vast distance between objects from us from our dangers out there, but we might get unlucky in the future. At some point, we could encounter a star-going supernova or massive object passing by and showering Earth with asteroids. If something like this were to happen, we would likely to know thousands, if not millions of years in advance. But we can't still do much about it. Unless we move our whole solar system out of the way. To move the solar system, we need a stellar engine, a mega structure used to steer stars through the galaxy. It's the kind of thing that might build in an advanced civilization with Dyson sphere levels technology that's thinking about their future millions of years ahead of time. But how do we possibly move hundreds of thousands of objects in the solar system? The good news is we can ignore all of that. We only need to move the sun. The other stuff is glued by gravity and will follow it wherever it decides to go. There are lots of ideas about what a stellar engine might look like and how it would work. We picked two in our current understanding of physics that would be built in theory. The simplest kind of stellar engine is the shadow thruster, a giant mirror. It works on the same principle as an rocket. Like rocket fuel, the photons release a solar radiation carrying momentum, not a lot, but a bit. For example, if an astronaut turned a flashlight in space, it would push them backwards very, very slowly. A stellar engine will work a little better than flashlight because the sun produces a lot of photons. The basic idea of the shadow thruster is to reflect up to half the solar radiation to create thrust and slowly push the sun where we want to go. In order for the shadow thruster to work, it must keep in the same place, not orbiting the sun. Although sun's gravity would try to pull it in, it would supported by radiation pressure, which props the mirror up. This means the mirror will have to be very light, made of micron-thin reflective foil from materials like aluminum alloys. The mirror shape is important too. Enveloping the sun in a giant spherical shell wouldn't work because that would refocus back the light on the sun, heating up and creating all sorts of unpleasant problems. Instead, we use parabola to send most of the photons around the sun and in the same directions, which maximize thrust. To prevent accidentally burning or freezing Earth with too much or too little sunlight, the only safe place to build a shadow thruster is over the sun pole. This means we can only move the sun vertically in the plane of the solar system one direction in the Milky Way. which limits our travel options. But that is basically it. For civilization capable of filling a Dyson sphere, it is relatively simple endeavor. Not complicated, just very hard to build. At full throttle, our solar system could probably move about 100 light years over 230 million years. Over a billion years, it gives us near complete control over the sun's orbit in the galaxy. But in short term, this might not be fast enough to dodge a deadly supernova. That's why we thought we could do better. So we asked our astrophysics friend as he could design a faster stellar engine for this video. And he did, and wrote a paper about it that's been published in a peer-reviewed journal. You can find out in the sources document. We're going to call our new stellar engine the Kaplan thruster. It works a lot more like a traditional rocket, shoots and exhausts one way to push yourself the other. A large space station platform powered by a Dyson sphere that gathers matter from the sun to power nuclear fusion. It shoots out a very fast jets of particles at nearly 1% of the speed of light out of the solar system. A second jet pushes the sun across like a tugboat. The Kaplan thrusters requires a lot of fuel, millions of tons per second. To gather this fuel, our thrusters use a very large electromagnetic fields to funnel hydrogen and helium for the solar winds to the engine. The solar winds alone doesn't provide enough fuel though. That's where the Dyson sphere comes in. Using its power, sunlight can be refocused on the surface of the sun. This heats small regions to extreme temperature, lifting billions of mass off the sun. This mass can be collected and separated into hydrogen and helium. The helium is burned explosively through thermonuclear fusion reactors. A jet of radioactive oxygen is a temperature of nearly billion degrees expelled and become our primary source of pollution. To prevent this engine crashing into the sun, it needs to balance itself. And to do this, we accelerate a collected hydrogen with electromagnetic field using a particle accelerator and shoots a jet back at the sun. This balances the thrusters and transfers the thrust of the engine back to the sun. As little as a million years, this engine can move the sun by 50 years, more than enough to dodge a supernova. At full throttle, the solar system can completely redirect it in its galactic orbit in 10 million years. But wait, will we use up the sun this way? Unfortunately, the sun is so massive, even the billions of tons of material will barely scratch the surface. In fact, megastructures actually extend our sun's life, since lower mass stars burn slower, keeping the solar system inhabitable for many more billions years. With a Kaplan thruster, we can turn our entire solar system into a spaceship. For example, by orbiting backwards in the galaxy and colonizing hundreds and thousands of stars as we pass by them. It may be even possible to escape the galaxy entirely and expand beyond the Milky Way. Stellar engines are kind of machines that built by civilization that thinking not in terms of years or decades but eons. Since we know that our sun will die one day, a stellar engine could allow the far future descent of humans to travel without ever having to enter terrifying dark abyss in interstellar space. Until we build a stellar engine, we adrift and subject to winds of the galactic sea. We may not like where it leads us. Maybe our descendants will set sail and become an interstellar species for millions of years to come. So that's the end of my recording, and thank you for listening. Bye.